56, find the standard deviation, make a bell curve for 70, 80, 95, and 75. Then also compute the z-score for 80. Okay, we good? Z-score of 0. And it looks like they found standard deviation, or the mean was 80. Let's see, 80. The only thing on the standard deviation, can you guys tell whether they divided by 4 or by 3 on that last one, that last mean? Look at it. They did 225 plus 25, that's 250, plus 100, that's 350. They divided by 4? So that means that is incorrect, right? Because for the sample, when we get to that spot, it's n minus 1. So you do what? Divided by what? By 3, not 4. Yes, Mr. Q. All right, good. So just double check that. All right. Thank you, guys. Appreciate it. Copy the agenda. Warm-up 56 done. Semester 1 concepts and skills. We're still in the middle of a study guide. Hopefully you guys already finished the multiple choice ones last night, or at least half of them. And once again, to access this presentation, here's the code, D5P9Z. Write that down, D5P9Z. The study guide is included in there as well. D5P9Z. All right. All right, get a blank sheet of paper ready, Cornell Notes style. We're going to go over some of those home plate problems that you did last night. So before I get started, I'm going to give you guys a head start. Check with your neighbor what you did for problems numbers 1, 2, 3, 4, 5, and 6 of last night's home play. Go over it with your neighbor. I'll give you guys some time for that. Then I'm going to go over these with you. Copy and go. Got about, I'll give you 7 minutes. 7 minutes. Looks like Bree's got this already. So let's go over what you guys went over with your neighbor in regards to what you did last night. Let's go with number 1. Here we go. Let me make some space here on your blank sheet of paper. If you have doubts on number 1, make sure you show your work on your paper, please, so you can have an example for that. It says, in the cafeteria, sometimes salads are served and sometimes fruit. So salads and fruit. Okay. Linda notes that out of 15 days, 12 days are salads. So how do we write that as a fraction? 12 over what? 12 over what? 15, yes. And that is for salads. Okay. But then it says 3 days fruit is served. So how do we write that as in a proportion? I mean a ratio. It's 3 over 15, and that's for fruit. So the question is, predict how many days fruit is served in a 180-day school. So that means we need to make a proportion. Do we use the first fraction or the second fraction? Second, because it's for the fruit. So we put equal to. We know that it's 3 fruits for 15 days. How many days are they asking us to predict? Where does that go? On top or on the bottom? 180. So on top we write x. So 15 times x, 15x, equals 3 times 180, that's 540. Divide by 15, divide by 15, x equals, is it 36? Correct answer is B. Check your work, please. Once again, if you didn't get this one, write that data down because you're going to need that information. You will get one of those at least on the final. All right, we good? All right. Let's go to number 2. Number 2. It reads, let me make some space here. Hold. All right, here we go. It says, a factory produces 28,000 computers monitors per day. The manager of the factory claims there are fewer than 870 defective computer monitors produced each day. Tell your neighbor, what ratio are we going to write for that so far? How do we write that as a ratio? Let me go to the previous one. The previous one, we said that the total number of days were at the bottom. Is that correct? So, question. How many total monitors per day? 28K, so 28,000. How many defective? Fewer than what? 870. So there's our proportion, our ratio. So far, so good? All right. So that is our proportion, our ratio. And then it says, in a random sample, 200 computer monitors, there are 3 that are defective. So 3 defective for every what? 200 according to the sample that they got. So the question is, determine whether the manager's claim is likely to be true. So it says, the manager's claim is likely to be true. The manager says, let's see, there are fewer. The manager of the factory claims that fewer than 870 defective monitors are produced each day. In a random sample of 200 monitors, there are 3 defective. So how can we tell whether he is right in regards to something like that? Fewer than 870 will be defective if you only got a sample of this. Well, set that as a proportion. So out of 200, there's how many defective that he found according to the sample that he got? 3. But in a day, how many monitors are produced? 28,000. So we want to know, according to the sample that they got, how many defective are we going to have in regards to the 28,000? So we write here what? X. Because he's claiming that 870 or fewer than 870 are defective. So from there, do we know what to do? Yes. Cross multiply. 200 X equals 84,000. Divide by 200, divide by 200. So, take away some zeros. 840 divided by 2 is 420. So, in 28,000, there are how many defective? According to that sample, 420. So, let's look at the options. It reads, the manager's claim is likely to be true based on the data. You can predict that there are 425 defective monitors. Is that pretty close? It's pretty close, so let's keep that in mind. No, the manager's claim is not likely to be true. Well, he was right. It's fewer than 870 are defective. Is that correct? So B cannot be true. So the no are eliminated. So let's look at C. Yes, the manager's claim to be true based on the data. You can predict that there are 420 defective monitors produced per day. So the correct answer is C. Does everybody see what we did? All right, all right. All right, make sure you make some notes on that. Let's go to the next one. I'm going to ask you to send me your notes in the screen that I'm going to send you in a little bit. Give me a second. Let's go to number 3. At Rosa's summer job with a research company, she must get representative sample of people from her town to answer the question about health habits. So here's the situation. Rosa's going to go asking people about what? Health habits. About what? Health habits. Okay. Now, when you are a statistic or a statistician, I told you guys that the sample has to be unbiased, right? It has to be like not leaning one way or the other. Which of the following methods could be used to get a representative sample? So let's see. A, selecting people who are in the hospital. B, gathering responses from women who own businesses in town. C, selecting people at random from a computer list. Or D, selecting every 10th person as they enter a fast food restaurant. Talk to your neighbor, let them know what is the answer and why do you say that. Looks like Mila's got it. I see you, Mila. Aubrey's got it. I see you, Aubrey. Let's go with Sadie. What you say, Sadie? Sadie says C. Hands if you agree with that. And why C, everyone? Well, let's start with the ones that are not. Selecting every 10th person in a fast food, is that a healthy choice? No. Selecting people in the hospital, no, they're already sick. They're already going to answer in regards to that bias. Gathering responses from women who own business, that's also biased because they're only asking women. So the only possible answer is C, selecting randomly. Let's go to number 4. Jean pulled a random sample from a population and calculated a sample statistic. What kind of statistic? A sample. Jean can use this statistic to draw inferences from what? A, corresponding sample parameter. B, population size. C, corresponding population statistic. And D, the corresponding population parameter. All right, talk to your neighbor, let them know which one do you think Jean could get information from that sample that she got. All right, let's see. Sadie, pass them on. Lucas, which one did your neighbor say? D. Hands if you agree with D, corresponding population parameter. Yeah, that is correct. Not population size, not corresponding sample, because we don't care about what that is. We're trying to focus on the entire population. So, let's go to 5. Match the sample of students with the correct sampling method. Every third student on the class list. Every third student. Tell your neighbor what kind of method that is. All right, pass someone, Lucas. Aaron, D. Hands if you agree with D. That is correct because it's every third, every fifth, every 10, so on and so forth. Let's go to number 6. Which survey question is unbiased? Now remember, unbiased. Biased, anytime you hear biased, is when they are trying to manipulate by you thinking whatever they want you to think. So bias is manipulation. Unbiased is not being manipulated. So let's see. Don't you agree that campus parking is a problem? B, saving money is important to you, isn't it? C, is Smith interested in the job? D, did Mary lift a finger to help? Tell your neighbor the correct one. Which one is the unbiased? All right, Aaron, pass him one. Jacob. Correct answer is C. Very well. Because here in D, they're trying to tell or manipulate you to think that Mary didn't lift a finger. Does that make sense? Kind of like saying, did LeBron do anything for the NBA? You see what I'm saying? I'm trying to manipulate, make you guys think about something. You know what I'm saying? All right. That was 1 through 6. Let's keep going. We got 7, 8, 9, 10, 11. I want you to go through those with your neighbor, please. 7 through 11, and then I'm going to go over those with you. I'll give you guys another 7 minutes. Go. All right, here we go. All right. Okay, I'll wait for you guys, but in the meantime, let me read number 7, and it reads, determine whether the situation is an example of an experiment or observational study. So, before I go over that, tell your neighbor the difference between experimental and observational study. What is the difference from one to the other? All right. Looks like Karime's got it. Very good, Karime. Caitlin's got it. Well, let's go with Haiti. What is the difference between an observational or an experimental study? Ooh, Haiti's from the corner. Let's go. Man, you should have been on the basketball team. Whew. Yes, observational, you just stand back and observe and get data from that. And experimental, you bring something in to manipulate the situation. All right, so let's read it. It says, a volcanologist is a person that observes volcanoes, compares average global temperatures in years where there was a major volcanic eruption to the average global temperatures in years without major eruptions. Is it an experimental or an observational? Tell your neighbor, what is that? Experimental, observational. All right, Hades, pass someone. Sammy, A or B? B. Hands if you agree with B. That is correct. You can't make a volcano erupt. You just observe it. And of course, number 8 is the same. Sorry, I did a duplicate, so it's also B. Let's go to number 9. Number 9, it reads, determine whether the situation is experimental or observational. Daryl wants to know whether his car will get better mileage with a certain fuel additive. You guys know what that is? At the gas station or AutoZone or those places, Walmart, they sell a little quart bottle of liquid that you can put in your car. So for those of you that fuel only 87, you're going to need to put that from time to time to clean your injectors. You're like, what? Yeah. Or either that or pump 91 always, even though it's a little bit more expensive, but that 91 has chemicals in there that clean your injectors. But anyways, it says, he fills his gas tank with an additive and drives until the tank is empty. Next time he fills the tank up and inserts the fuel additive. So one tank without, one tank with. Tell your neighbor, what kind of study is that? What kind of study is that? Sam, pass on one. Sebastian, A or B? You said B? And why do you say B? Yeah, but what makes it experimental? Yeah, you're adding, even the word says additive. You're adding something to the experimental situation. All right, let's go to the next one. Number 10. Camille gives a survey to two groups of people. One group uses high sulfate laundry detergent, and the other low sulfate detergent. Tell your neighbor what kind of study is that. Sebastian, pass them on. Who? Jordan. Said 8? And why is that? Yeah, you're changing stuff. That is correct. 11. You want to know if the children of musicians are more likely to learn to play an instrument. Think about it. You want to know if the children of musicians are more likely to play an instrument. Talk to your neighbor, let them know which one you think that is. All right. Jordan, pass someone. A, observational. Hands, do you agree with that? That is correct, because you can't manipulate the situation. You're just observing. I want you to do number 12 by yourself. This is very similar to the one that we did for number 2 and 3. Very similar. See what you do for that one. What's that? Oh, yeah. Sorry. Focus, you're doing number 12 by yourself. You should be able to do that one by yourself. I already did a couple of them at the beginning with you for that kind of situation. All right, show your neighbor what you did for that one. You should be able to finish by now. Then we're going to pass it to someone so they can walk us through the process. Who was the last one that went? Levi? Okay, Levi's going to pick someone in a little bit. All right, it looks like Gio's got this one already. I was barely going to pass it to Adrian, but said, I got this. All right, Gio, you said what? B. Hands if you got that. That is correct. So you should have written your first ratio of 399 over 400. Is that correct? But then they want you to predict how much it would be in 1600. So you write X, cross multiply. Oh, in person. Let it go. Let it go. So this is 400X equals 1600 times that. That's a lot. Is it, let's see, 4, it's 63,996. Is that correct? Yes, no, maybe so? Am I missing a zero or? Probably a 0 or 2. Divide by 400. So x equals 1596. All right, we'll stop right there. Tonight, continue working on those multiple choice ones. We're going to finish off tomorrow. So make sure you're putting in work, people. Finals coming up next week. One of your colleagues suggested on Monday to get started. What? Anyways, those of you following on YouTube, make sure you put some work in. See you guys next time. Peace.